Hello everyone, Ramya, Assistant Professor of CSC Department from Rohini College of Engineering and Technology, subject code CS3352, Foundations of Data Science, Unit 4, topic Basics of NumPy Array. Basics of NumPy array. NumPy is short for numerical Python. It provides an efficient interface to store and operate on dense data buffers. NumPy arrays are like Python's built-in list type, but NumPy arrays provide much more efficient storage and data operations as the array grow larger in size. Here we have some categories of basic NumPy array manipulations are attributes of array, that means it determines the size, shape, memory consumption and data types of arrays. The next one is indexing of arrays, means getting and setting the value of individual array elements. The next one is slicing of array, means getting and setting smaller sub arrays within a larger array. The next one is reshaping of arrays, changing the shape of a given array. The next one is joining and splitting of arrays, combining multiple arrays into one and splitting one array into many. Next, we are going to see some array attributes. NDIM, that means it represents the number of dimension. Shape, it represents the size of the each dimension. Size, the total size of the array. Here in one example, it shows the how we are going to fix the size for if you, for example, x1 equal to np dot random dot array 10 comma size is equal to 6. It is a one dimension array. Likewise, you have to represent for two dimension array. Likewise, you have to represent for the three dimensional array also. This is a sample example for the NumPy array attributes. Next one is accessing single elements. That means indexing in NumPy will feel quite familiar like list indexing. In a one-dimensional array, you can access the value by specifying the desired index in square bracket, just the Python list. The next one is to index from the end of the array. You can use negative indices. In a multiple dimensional array, you access items using a comma separated tuple of indices. Unlike Python list, NumPy arrays have a fixed type. This means, for example, if you attempt to insert a floating point value to an integer array, the value will be silently truncated. The next one is array slicing, accessing subarrays. It can be used square brackets to access individual array elements. We can also use them to access subarrays with a slice notation marked by a colon character. Here the NumPy slicing syntax follows of the standard Python list. The next one is your multidimensional subarrays. The multidimensional slices work in the same way with multiple slices. It is separated by commas. Here one sample example for the multidimensional subarrays. For example, in the array you have the 4 columns and 3 rows. It represents some set of array elements. Likewise, you have to separate how much rows and how much columns you want. Finally, the subarray dimensions can be reversed together. The next one is reshaping of array. The most flexible way of doing is in the reshape method. For example, if you want to put the numbers 1 through 9 in a 3 cross 3 matrix, means you can do for grid equal to np dot arrange of 1 comma dot reshape of 3 comma 3. Here 3 comma 3 means it represented as a 3 cross matrix. np dot arrange of 1 comma 10 means your value should be 1 to 9. Next one is array concatenating and splitting. Concatenation of arrays. Concatenation or joining of two arrays in NumPy. It is primarily accomplished through the routines np.concatenate, np.vstack and np.headstack. np.concatenate take a tuple or list of arrays in a first argument. The next one is splitting of arrays. The opposite of concatenation is splitting, which is implemented by the functions np.split, np.hsplit and np.vsplit. For each of this, we can pass a list of indices giving the split points. Thank you.